Hello, Tobias here. Today I'm going to show you how to build this architecture. This is a really cool architecture pattern based on serverless services at AWS. This one, what it can do is it can take requests from the internet to the API gateway, and then once here, if there's a route that matches on the gateway, it'll perform an operation on DynamoDB. An operation could be something like fetching items or putting them or updating them. So if we just go a little bit further into what each component does, so this is the API gateway, the REST version of it. There's two versions, there's the HTTP version and the REST version. The REST version is more powerful and is more expensive, and we're using that one here. And the way it works essentially is you define a route on the gateway, so you might define something like /pets, and then you define the method like post, and then you define what happens. So in our configuration, if there's a post on /pets, an operation is performed on the actual DynamoDB table. Now we do have several Terraform configurations that we have to create in order to deploy this. The first one is this. It is the gateway itself. It has a bunch of configuration parameters that we'll get into in the coding section of this. We have the deployment, and the deployment is essentially a snapshot of the configuration at a given time. It's like when we deploy and make a change. We have a stage, so there can be different what we call lifecycle states for the gateway. There can be prod, dev, test, staging, etc. So we create a stage. And then when it gets to defining who can actually use the gateway, we need two things. We need to create a usage plan, and this defines things like maybe some throttling parameters and other security features if we need them. And we can also define an API key. So we define the plan, the key, and then we use this resource right here to tie them together. And then in addition to all those resources, there are several IAM resources that we will use to connect everything and make sure they have the proper permissions in the cloud. Okay, that was for API Gateway. On the DynamoDB side, for those who are unfamiliar, DynamoDB is a managed database service. It is not a SQL type database. It is what you refer to as a NoSQL database. There's still tables, there's still columns, there's still rows, but you can't, join two tables together with a query. There are data modeling strategies where you can get things that are like related data. It's a little bit outside the scope of this tutorial here, but that does exist. And luckily on the Terraform side, this configuration is super easy. We have one resource, it's our DynamoDB table. We do specify things like the name, the billing mode, and some other things we'll get into later when we start coding, which will be momentarily. So yeah, that was the overview, and now let's get to coding. If you are using SkillMix to complete this lab, you can now go to the diagram, click the lab is offline, and then click Start Lab. And this will provision an Amazon account for you. And just wait until all the details are filled in. Okay, great. What you need to do now is go configure your Terraform project to use this access key and this secret key. And once you do that, you'll be able to proceed with coding. Let's create our Terraform code now. Open an editor that you like and then create a folder somewhere. I'm using VS Code and this is my folder name. And what I want to do right now is create the main.tf file. And the first thing we'll put in here is the Terraform provider block. So this is a required block when you're creating a Terraform project. And what we're doing here is we're specifying our required providers. We are requiring the AWS provider that's sourced from HashiCorp. And we're pinning this to 4.48, which is the latest version as of this recording. We are also pinning this project to Terraform 1.3 itself. So we have that. The next step is to configure our provider, and we'll do that with this block right here. We are specifying that we're going to use the local profile. This profile, really what that means is that there's the AWS CLI that you have to have installed on your computer to use Terraform, and in that AWS CLI you can do named credential sets, and this is the name of my credential set. and then we are specifying that we're going to work in the US West region 2. Next up, we're going to create 2 data blocks. The first one is going to get our caller, basically the identity of these credentials. And that's nice because it gets the account name or the username, and it gets the ARN, etc. And then we're going to use the region block as well here, and we can refer to that later on in the code. Now we're going to get to building out the API gateway resources. The first thing we'll do is we will create a little section here that says this is for the API gateway resources, and then we'll create the API gateway itself. The first attribute is just the name, and then the next one is the body. And this actually is quite complex, so I'm going to piece this together. So the first thing that we'll do is create the first part of the body. This body is actually an open specification based on OpenAPI, and there's a bunch of docs out there that go into details about what this body should look like and what you can configure in it. We are configuring some information about the API, so that's just some friendly stuff there. We're setting a base path of /v1. We're enforcing SSL by using the HTTPS scheme. And then we start to really define our paths that we want the API gateway to be configured with. The first one is /pets. And we're configuring the post method on that. So we're going to specify that we're using JSON. You can configure responses, so when there's a HTTP 200, we will respond with this text. And then we are using the security key authentication method. The next bit here that we're going to configure is really the kind of meat of the DynamoDB integration. And Amazon has this special block within this JSON file that they specify how to configure it. So this is a type AWS. We're using the credentials from a role that we'll create in a little bit. This is making a post request to DynamoDB. And then we specify the URI. This can be an HTTP endpoint, or it can be something else. In our case, it's the URI to DynamoDB and to specifically the put item. We can also specify shape our response here, and we're just going to go with the default settings. And then this is probably the more interesting part. If you're not familiar with DynamoDB, it does have a specific API kind of body that you have to use to do things like put or get items. And that's what this is right here. If we were to unescape this and format it, you would see that it's the structure of the DynamoDB API. Okay, great. And then there's some configuration here about if there are no templates, what to do. And this essentially enforces the request to go through in JSON format. Okay, so that's for the /pets. And then we have one more endpoint that we'll configure, and then we'll be done with the API gateway. So this endpoint here, okay, let's get reset here. This is the pets/pet type. And when someone does a GET request on this, we want to return the detail of that pet type. Again, we're using JSON here. We are specifying some parameters, so the name of the parameter is pet type. It's going to be in the path. It is required, and it is a string. So these are the details of the parameter that we're accepting. I'm just going to jump to what's new here. If you look at this again, the Amazon API Gateway integration, we're using the same credentials as the last time. This will make a post request to DynamoDB as well, but you can see instead of a put, it's doing a query. We do shape our response, so this again is using some DynamoDB specific language to shape how the response will be formatted. And when we get to testing this, you'll see that response. We do have, again, our request parameters. We are enforcing that the pet type parameter is in the request. And we have another request template here that you can see and read. And then lastly, we do have a security definition. We are using an API key, and it will be in the header formatted with, that will be the name of the header key when we make requests to this. There are still a few more resources that we have to create. The next one is the account setting resource. And this is a generic resource that we use to set certain things about our API gateway account. And here we're setting the CloudWatch role ARN. This role is not yet created, but we will do that soon. Okay, so let's go ahead and do that. We will create the role right now. So this is a role that the gateway will use to log logs to CloudWatch. And we do have to set, when we create the role, we do have to set the access to the actual gateway service. So that's what this first policy does here, the assume role policy. This gives the API gateway service the ability to interact with this role. Next, we'll create a policy for actually logging. And that policy will look like this. So you'll notice that we have the AWS IAM role policy, and then we give it a friendly name. Here we're actually tying the policy that we're creating here to the role that we just created. So if you can see that name, that's the same as the one here. So this policy is being attached to that role, and it lets us log events essentially. Next up, we're going to configure the gateway to push the logs to CloudWatch, and we do that with this method settings. So we're tying the REST API we created above to the stage name, to our path. So we're doing an anyPath wildcard here, and we're saying that we want to log the info level to CloudWatch. We do need another role, so this role will be used to interface with DynamoDB. So let's go ahead and do that now. So this is an IAM role for gateway, another one again. We are giving the gateway service the ability to assume this role, and then we will create a policy that lets us log to DynamoDB. So this policy here, you can see it's giving us the put item and query item. And this is the resource of our DynamoDB table. We haven't created that yet, but we will in a moment, and you'll see the path as well. And for this one, we're gonna create another Terraform resource that will attach the role that we just created to the policy we just created. Okay, so you can see that with the role and policy right there. That's it for the API gateway resources. Let's move on to the DynamoDB resource. Next, we are going to create a few more resources that help us finish the configuration of the API gateway. The first one is the deployment. And deployment is essentially a snapshot of our configuration. And we don't use it alone though. We use the deployment with a stage. So we'll do that now. So here we specify the REST API ID that we just created above. And then we create a stage. And a stage is a lifecycle state. So a stage can be something like prod, dev, test, etc. Here we're linking to the deployment ID that we just created. We're tying it to our REST API that we created. And our stage name is going to be V1. And we will make this depends on the account setting resource. Okay, great. Next up, we're going to create a usage plan. A usage plan is essentially determines who can do what on the gateway. So if you wanted to say set a certain quota for a user, you can create a plan for that quota or for that user. So you'll see here that we have in this plan we have 1,000 requests per month, and we do have some throttling settings as well. So this is super helpful. And then you actually take that plan and you tie it to a key. So next thing we need to do is create an API key itself, and it's pretty straightforward. It's just this resource and we set its name. And next up we tie the two together. So we have our plan, we have our key, and then we create a kind of a binding between the two with this resource. So that's our key above and our usage plan. This next set of resources is all about CloudWatch logging and the IAM resources to make that happen. So the first thing we do is we create the gateway account resource. And what this does is it sets the CloudWatch role that will be used for logging. And we'll go ahead and create that role now. So then we add the actual CloudWatch role here. And this one is pretty straightforward. What we're doing is we're assigning the assume policy, and this will let the API gateway service assume this role, which is needed for it to perform its actions. Now we'll create the policy for this role. And this policy, we want it to actually help us or enable us to actually create the logs. So we're giving it the role policy resource, giving it our friendly name, and then we're going to relate it to the role that we just created with this attribute right here. So it points to that role right here. And then for the permissions, it's an allow statement that gives us access to create logs and put logs and stuff like that. Okay, so now we can access CloudWatch logs. We do have to do one API gateway related resource, which ties or basically relates what we just did to the gateway that we just created. So this resource, it points to our REST API, it points to our stage name, and we're going to basically filter on all paths. And then we enable the metrics and we set the logging level that we want to log. And that will help us log from our stage name on the API gateway. We are going to create another role as well. This role will be used for putting, or basically for access to DynamoDB. So this role, we're giving it access to the gateway can assume this role, and this role will be able to essentially interact with DynamoDB. So the role name is here. This is the policy here that allows us to access DynamoDB on our resource. And then we are going to connect the two, the role and the policy, with this last resource right here. So here's our policy attachment, give it a friendly name, our role, and our policy arm. That wraps up the API gateway resources. We are now going to move on to DynamoDB. Luckily for our project, the API gateway was the most complex part of the configuration. The DynamoDB part actually is quite simple in comparison. All we have to do is create one resource, and I'll show you that right now. So we have the marking of the new section, and then we have our DynamoDB table. We give it a friendly name, we set the billing mode type to provisioned, and we set the read and write capacity, and then we identify the hash key as ID. And then we set the attributes. So again, we set the ID attribute, and we make it a type of string, and then we create another attribute called pet type, and it's also a string. And lastly, we create a global secondary index with the hash key of pet type, and this will allow us to do operations basically using the pet type hash key. Now I'll create a few CloudWatch resources. The first one we're going to create is the actual log group, and we give it a prefix so that we can find it in the console. And the next thing we'll do is create a policy that allows us to create log streams and put logs. And we do that with this resource. And you can see we are specifying the log group that we just created here. Okay, so we have all of our resources created. Let's create a few outputs that will output values to our terminal when we run the terraform operations. The first output that we want is the API gateway URL, and we refer to the gateway stage here so that we can get that value. The next one is the API gateway key, and we refer to our plan key as well. So now when we run the terraform commands, like we will in a second, you'll see these outputs if everything works well. Let's now open up a terminal and execute our terraform commands. The first one we want to run is terraform init, and this will prepare the environment for us by downloading plugins. Great, now we want to run terraform plan, and this will come up with a list of proposed changes. And we can see here we're creating 16 new resources and we have 2 outputs. And now let's run terraform apply and see what happens. We will need to confirm that we want these changes to be made, and then we are off to the races. There are 2 commands that we can run to test that our system is working. The first one is this post request, and you'll see that we have put in our API key to the header here. So that's the first thing you need to make sure that you do. And then you need to make sure that you put the URL of your API gateway after this post text. And then we have /pets. And then here is the data we're passing in. So the pet type is dog, the name is Tito, the price is $2.50. So if we run that, it should come back with %, and then we can query our new pet type. So this is the second command that we can run. This is again our API key, and this is the URL. But if you recall back to our API configuration, we have to put a new dog type / at the end. So the dog type is, or the pet type is dog. And then if we execute that, we get back our record in the database. And voila, it's working. You can run terraform destroy now to tear everything down. Thanks for joining.